let's take a look at these two problems. We want to find all rational zeros for each of those polynomials. Now, to narrow down our choice of zeros, let's make a list of possible zeros first. So the list of possible zeros, we look at the constant term here, we call this P, and we're looking at the leading coefficient Q. So P over Q would be 6 over 2. Now we're finding all the possible factors of 6, and I usually put them in order. This also includes the negative numbers, so we can just write plus, minus, 1, 2, 2 times 3 is 6, and 6. And then we find all possible factors of 2, which of course is just 1 times 2, or 1 and 2. Now our list is now a combination of the numbers on top, first of all divided by 1. So that would be plus, minus 1, 2, 3, and 6. And now we're looking at a combination of all numbers on top to be divided by the next value in the bottom. Don't call it numerator and denominator because it's not actually a fraction. And that would be 1 over 2. 2 over 2 is 1. We already have this 1. 3 over 2 is the next possible 0. 6 over 2, if I reduce it, it's 3. We already have that listed there as well. So the possible zeros here we have is plus, minus 1, 2, 3, 6, 1/2, and 3/2. The degree of this polynomial is 3, so we have to find 3 zeros. And the way we do that is we use synthetic division, and we pick one of those numbers from our list. And when the remainder is 0, great. We found a 0. If not, we have to go to another number. So let me write out my coefficients, which are, first of all, in descending order. There's no missing term, so I have a 2, a 1, negative 13, and a 6. And I start with positive 1. So now I'm going to see, does 1 work? Is our remainder 0? So the first step is you bring down the 2. 2 times 1 is 2. We add, plus 1 is 3. Then we do all over again. 3 times 1 is 3. Plus a negative 13 is a negative 10. A negative 10 times 1 is a negative 10, plus 6 is a negative 4, and you can clearly see that 1 is not a solution. Let me just jump out here, and I want to erase this. So let's try. Now what we normally would do, if I was at home, I would try negative 1. And you see that negative 1 doesn't work either. So let's go and try 2. So now I'm going down the list, and 2 is my next number. So let me change colors. Again, we bring down the first 2, the leading coefficient, and now we multiply 2 times 2, which is 4, and we write that underneath the second coefficient, and we add, we get 5. 5 times 2 is 10, plus a negative 13 is a negative 3. Yes, negative 3. Negative 3 times 2 is a negative 6. Oh, how did I know that? Oh, surprise, surprise. Here you go. You just found your first 0. That is where the graph crosses the x-axis. It's crossing at 2. Because our remainder is 0. Now, how do we find the other 2 zeros? Well, we rewrite this last row here. These are my coefficients for my next polynomial if I bring back the x variable, but now this x variable is 1 degree less than what I started with. So this becomes 2x squared plus 5x minus 3. And this is the trinomial now that I have to solve either by factoring or by quadratic formula. In this case, we can see if we can factor this trinomial. Let's see, we need 2x here and an x here. My last term is a 3, so I'm putting a 3 in here and the 1 there. I need a positive 5, so if I make 2 times 3 is positive 6 and a minus 1. Here you go. 6 minus 1 gives me that positive 5 in the middle, so I could factor it. Great. Now let's set each factor equal to 0. If you solve for x, you get 1/2. X plus 3 equals 0 and x equals negative 3. Great, here you go. We just found our 3 zeros. Don't forget x equals 2 from our initial guess. This is one problem. Now let's take a look at the other problem. Here we are to the 4th power. So now we have to find 4 zeros. But first of all, let's do P over Q again, and I can put this up here. P over Q, our P constant term is 12, and that is over 1, so that's kind of nice. So our list of possible zeros are just the factors of 12. 1 times 12, 2 times 6, 3 times 4, 6, and 12. I always like to write them in this order from low to high. Okay, now again, we need to use synthetic division, but because the degree is 4, we actually have to do it twice. So let's write out our coefficients. There is not a missing term. Everything is in descending order. We have a 1, negative 1, negative 13, 1x, and a 12. And again, when I pick my first 0, I always pick 1, either 1 or negative 1. So let's see if 1 works. We bring down the first coefficient, which is a 1. 1 times 1 is a positive 1, plus a negative 1 is a 0. 0 times 1, you see how the math, the multiplication is pretty simple. That is 0 plus a negative 13 is a negative 13. Negative 13 times 1 is still negative 13 plus 1, negative 12. Negative 12 times 1 is a negative 12. Oh, look at this, beautiful. Our remainder is 0. So that means we just found our first value where the graph, if we were to graph it, crosses the x-axis. Now we're going to have to do synthetic division again. So twice. We want to do synthetic division as long as our last row turns up a quadratic equation. So right now we are at the 3rd power. We need to do one more synthetic division to get the polynomial down to the 2nd power. So again, your last constant term is 12, so the same list of possible zeros as I have on top still applies. Now we could use 1 again, but you would see it wouldn't work. So let me go to negative 1. Again, on paper, if you were to do this in practice at home, you would start with 1 again, do synthetic division. Your remainder probably is not 0, then you go to negative 1. So I'm bringing down the first coefficient, which is 1. Negative 1 times 1 is negative 1, plus 0 is negative 1. Negative 1 times negative 1 is a positive 1, plus a negative 13 is a negative 12. Negative 12 times a negative 1 is a positive 12. Oh, look at that. It's like I knew already that this works. So your remainder is 0. Now we're going to write it out. I guess we could use synthetic division again. But I want to change this now into into a trinomial with degree of 2. I did synthetic division twice, so my degree changed here. This was an x to the third. Now down here, 1 degree less is x to the second. So this becomes x to the second minus x minus 12, and that is the quadratic trinomial that I now have to solve either by quadratic formula or factoring. It just so happens that we can factor this one. We need a negative 12 and a negative 1, so we factor this into x minus 4 times x plus 3. Set each factor equal to 0, and you have x equals 4, and on this side we get x equals a negative 3. Now all the zeros are x equals, we started with 1, then we have a negative 1, we have a positive 4, and we have a negative 3. Here you go. We found all 4 zeros. That, if we were to graph it, is where the graph crosses the x-axis. That's it. Finding rational zeros.